So good morning, everyone that it's on West Coast, and good afternoon, everyone that it's in Europe, and probably good evening, anyone that is currently in Asia. Thank you, Annie, for introduction. My name is Karolina Socha, and I've been an IBL researcher, formerly working in Cortex Lab, and now I'm currently assistant project scientist at UCLA at Hack Lab. And I'm going to talk about recordings, techniques, particularly focusing on acute recordings. And I just wanted to briefly introduce the International Brain Laboratory project, which I've been taking a part. It's because like most of the talks are related to IBL. That was a project that involved 21 labs across the world. And our goal was to build a huge brain-wide map of activity during decision-making task. So we actually perform collectively like more than thousands of insertions with neuropixels probes during behavior. And currently, this project it's actually ending. So the output are the data that it's now available. And today you will have like some courses on how to use the data set. But I've been like one of the person that was recording from multiple brain regions for that project. And just to give you like a little bit of overview, IBL decided to, as an IBL, we decided to perform acute recordings that I will soon say what is it about in next slides, from entire brain regions. So obviously there's no technology that will allow you to record from all of the brain regions in the mouse brain. So we used acute recordings to put the probes in specific locations. We created a map for ourselves where this location should be. The density, it's like 0.5 millimeter, that the probes were recorded like 0.5 millimeter apart. So the data that has been actually released contain all of the brain regions from the mouse cortex. And we use the geometry of neuropixels probes that are very long. So we've been recording in the shallow part of the brain regions and much deeper parts. So we kind of experience all of the obstacles that might happen when you do acute recordings. So just to a little bit introduce acute recording. So as Cillian mentioned, chronic recordings, this is a great technique when you have brain regions that you want to record over days. The probe is basically attached to the skull for many weeks. However, if you want to change the location or you have multiple locations that you are interested in, the chronic recordings might be a little bit challenging because you might not have you don't have a flexibility to change the location of your probe. So acute recordings, that's the advantage of that you can use in head-fixed animals when you want to record from maybe multiple brain regions. You want to insert the probe every day to different location to map carefully some specific brain region. And acute recordings, definitely, it's not for freely moving animals or recordings from the same neurons over days. And as I mentioned, advantage is that you can gain a lot of data from many brain regions, from multiple probes simultaneously. You have more flexibility with insertion angles. And you can, of course, also combine with other techniques such as optogenetics or wide field imaging. But the disadvantage of acute recordings is that it lasts only a few days because it depends on the condition of the craniotomy, and you cannot track neurons over days. And also the craniotomy quality can decay, especially in the cortex. So over time, that you might actually see less and less activity in superficial part of the brain. So now I'm going to focus more on like practicalities related to performing surgeries for acute recordings, and also the setup itself and recordings. So I'm going to start with surgeries. It's very important that you will think already about a design and location of your head plate implant, because that will determine accessibility to brain regions that you might be interested. So if you will implant the head plate posterior, it gives you like more access to dorsal cortex and anterior areas. Whereas implanting head plate more anterior, you will have access to cerebellum and partly dorsal cortex. And there are many different designs of head plates. So depending on your needs, you might actually look and just adapt for your research. I wanted to just mention like interesting design from developed in Allen Institute, where they actually remove a big chunk of skull and cover with and cover with a part that has a drilled holes, so it's kind of prepared already for acute recordings from multiple regions. But you don't need necessarily use this implant. You can also go with more conventional. This is example of the head plate design that has been adapted from Svoboda Lab and used in IBL project. But as I mentioned, many different designs, so it's very easy to find them. It's just remember that this design will also determine like the stability of your recordings, and just make sure the design that you are going to use, it's also help in handling and head fixing the animal. What is important during performing surgery of implantation, the head plate design, is measuring the lambda bregma distance, because then you might assess whether or correct the coordinates for craniotomies that you want to do in the future. So it's important to measure this, because the skull of the size of the skull is always different in different animals. And what I recommend, it's already mark a location of your future craniotomies, because it will give you a sense whether you have access to those and you can do easy the craniotomy. And if not, then you need to think about planning your craniotomies differently, or putting the probe in different manner. But at that stage, you will already have information whether you will have access, easy access to the place you want to record from. And another important point is to protect your skull. You need to cover skull with something. There are different ways, like for example, Zappa glue or adhesive resin cement, Metabond. You can also use UV curing optical adhesive. So all of those will nicely cover your the skull and keep it easy access to future craniotomies locations. And also consider printing like 3D well, which it's important to keep a saline inside and prevent from the leakage during recordings. That leakage can cause some kind of noise. The next step that you will probably have to do once you have NeuroPixels probes box, you need to actually mount them and adapt to your setup. So NeuroPixels probes do not come with a grounding wire attached, so that's something that you will have to do manually. So what I usually do and recommend, it's first to check your probe if it's working. It's like, of course, all of these probes are working, but that's a good routine just to capture at which moment or which step of your preparation you might actually accidentally damage the probe. So I typically just connect the probe that is inside the box to just see if it's working, and then I start preparing the probe by soldering the grounding wire. There is already videos that you can actually use as a guidance how to do that. This is example of the probe with grounding wire. Then you mount your probe, and IMEC already sells probes with a cap and also holders. So you can order this together with your NeuroPixels probes. But if you use some manipulators, for example, from NewScale Tech, there are other ways of mounting these probes, and there's also documentation how to do that. But this is like relatively easy. What I recommend is once you use a conventional holder that it's sold by IMEC, once the probe is mounted, just tape around, because the head stage, if you mount the head stage, this part becomes heavy and might actually bump into your shank. So always remember to secure. The last step that I recommend is sharpening the probe. It makes your life very easy and insertions very easy. Here I'm just showing example of the side view of the probe shank before and after sharpening. But then that sharpening allows actually probe to really nicely slide inside the brain without actually poking or trying to penetrate without damaging the brain. It's still, you can insert probe without sharpening, but it just makes everything easier. So I highly recommend doing that. So at the end of this steps of preparation your probe, I again recommend you to connect your probe to the setup and see if it's still working, if you didn't damage or didn't break anything. The next step, and my recommendation will be to think about what exactly you want to do for your experiments and which kind of manipulators you need. I just wanted to give a heads up that there are manipulators from SensaPex or NewScale Technologies that actually allow you to put a lot of probes, and they have this mounting rig that it's very convenient for multi-probe recordings, because you can easily change the angles and the number of probes that you can mount can be high. So it's a very convenient way for if you have a desire to do acute recordings from 4 brain regions. Otherwise, there are plenty of other manipulators that you can also use, so depending on your budget. Before you start your experiments, you of course have to plan your trajectories and where you are going to insert the probe. There are already talks at this course how what are the available GUIs, but I wanted to just give you a heads up that right now both GUIs they have very useful feature that actually provide like better control during probe insertion and recording. So you can actually see exactly the position of your probe when you are moving the manipulators, because those software actually there's interface between OpenEFIS or SpikeGLX. And also you can see visualization of which channels are where exactly inserted. But this is something that you will probably know better after the session on planning trajectories. So now I'm going to move to a practical part when you have a setup and you want to do acute recordings. Remember first to put the probes in saline, debug issues and grounding before performing any craniotomies. That might take some time. It's sometimes very frustrating. Everyone had to go through this. You are not alone with that. But this is important that you will do that before you start your experiments, because if you don't have a good signal from the probe in saline, it means that you have very noisy setup. So putting the animal to this will only make things worse. Remember to plan your probe trajectory. and position the manipulators before you put the animal there, just to see if you have space and if you want to use specific angles, if you have access, if you will have access to the brain. When this is like everything ready and the only part is to do a craniotomy, what I recommend is like to use a fresh craniotomy. For acute recordings, you will have just a good quality recordings. Typically, depending on your protocol, it can be done like 3 hours before recordings or day before recordings. Smaller craniotomy will give you a less movement of the brain, but you cannot, for example, insert 4-shank probes. So you need to also decide how big the craniotomy is, but smaller, it just gives you a better stability of recordings and less unit decay over time. Remember to attach a grounding pin. Typically, it's touching the dura in, for example, cerebellum, and cover your craniotomies with quick cast or quick seal. So at the day of your recordings, what it's useful to do is to label your probes with fluorescent dye that will allow you later to reconstruct the probe location. This is the 2 standard dyes that you can use, CMDI or DIO. And you can label them, for example, by lowering your probe on the setup, putting the drop of this dyes on parafilm and just dipping them for 1 minute. And that will be enough to see the probe trajectory in post-histological analysis. Lastly, check if your probe is detected. Sometimes there are some issues at the level of the setup or connection. So always check if the probe is connected, it connects to software that you use before inserting the probes inside the brain. Connect the ground pins to the probes, and what is useful is to zero manipulator position above the bregma, and that also allow you to have a better precision where you are going to record from. And here I'm just showing you example of recordings with 4-shank probes, acute recordings. And this is example of like how the raw data look like from these recordings. So you should to see clearly spikes on your setup while recordings. Sometimes the animal might make some movement which create a little bit of noise, but as long as this doesn't saturate your signal that you are detecting, you will be fine in post-op, in post-analysis, in post-processing, because that will be easy to be removed. And lastly, about like general tips about inserting the probes. If you insert inside the brain, you need to think about how fast you are inserting. If you insert very fast, you might actually wait 20 minutes until the probe will settle in the brain. The fast inserting might actually cause also that you might have less units. So my recommendation will be insertion of the probes with lower speed to just create a less damages in the brain. So your quality of the data can be much better. And you typically just wait around 10 minutes after insertion of the probes, just to make sure that the brain relaxed and you won't have a big drift, the drift at the beginning of the recordings. This is just general recommendation if you are going to perform recordings from deep or lateral brain regions. These are tricky regions because the probe might touch the skull edge. So usually what I do, I insert probe at the location where I think the probe is going to hit the skull very slowly, and observe the probe shape under the microscope. So if I see that probe starts deflecting, this is the sign that it's hitting the skull. So you don't want to press more. You want to actually retract the probe so it's straight. But these probes are very flexible. So once you will see this change of curvature of the probe, it's not necessarily the case that the probe will break immediately. It will break if you will keep pressing down. So that's my recommendation. Just always keep your eyes on your probe once inserting, just to capture quickly this kind of situation. And the most common issues with recordings are, of course, grounding. So this is example here of a signal where it's very noisy. The ground pin wasn't connected, and this is how it should look like. So when the ground pin is connected and your setup it's that there's no noise in those recordings. So just remember to check the connection with the probe and ground wire. Sometimes these ground wires, for some reason, you have to change or they break, so doesn't connect very well. Check soldering if it's really soldered with the probe. You might try to use different references. There's also option to use internal reference. Typically, we use external, and you have to identify the source of noise and just make sure that you make a proper grounding and isolation of the setup, because the worst thing you want to do is actually proceed with recordings, and then what you have, it's only noise. And just last two slides, just remember to keep an eye on the signal quality when you are inserting the probe. As I mentioned, fast insertion might cause that you won't see a signal in your setup. So then you have to wait if you will see new spikes. So I recommend inserting probe slower, and of course protect your craniotomy and maintain craniotomy. And these are just like links to the resources. And I wanted to thank you for your attention.